Hello, students. It is time for our lab activity regarding phase changes. Now, normally, what we do during this lab is all of our groups are given a test tube like this with paraffin wax, candle wax inside the test tube. And we put these test tubes into a pot of boiling water. So think about what the temperature is of boiling water. And as you can probably imagine, boiling water around this test tube warms up the test tube. The heat energy is absorbed into the wax, and the wax melts so that it becomes a liquid. And we have a thermometer in the test tube, and we record the temperature of the hot liquid wax. And then we take that test tube of hot liquid wax and we put it into a beaker of cool water, and we watch what happens to the liquid wax, and we watch what happens to the temperature. Now, I'd like you to make sure you're opening your book to your lab page. And with that in mind, I want you to think about the problem of today's lab, which states, what happens to the temperature when a substance goes from a liquid to a solid? So basically, you're going to be watching wax freeze today. It's going to go from a liquid to a solid. And the question is, what happens to the temperature when a substance goes from a liquid to a solid? So before you continue with this lab activity, I want you to pause and make sure you write a hypothesis. What do you think will happen? All right, so here again is an illustration of our lab activity, and you can see we've got a test tube with wax in it, and we've got a certain volume, 300 milliliters of cool water surrounding the test tube, and you're going to watch and see what happens to the temperature as the wax goes from a liquid to a solid. Now, since we may not be able to see this in real life, this week, I have a video that I'm going to show you that I found regarding another substance called stearic acid. We used to use stearic acid with this lab years ago, but I have found wax, paraffin wax, actually works much better for our purposes. So if we get a chance to do this in real life, we'll be using wax, but the same thing happens with this substance called stearic acid. So we're going to watch this video right now, and then we will gather some data for our own lab. So check it out.
So here we've got a temperature sensor connected to a data logger to my computer, and a graph is being drawn of temperature against time. And it's of this stuff, which is stearic acid. And the stearic acid has a temperature probe, and the temperature probe is connected, as you can see, is right inside the acid. So it's going to measure the temperature inside as this cools down to room temperature.
So
we've left this experiment for 40 minutes, and now you can see that the stearic acid has all solidified. The graph that we produced looks like this.
Now look at its shape.
Let's take a look at the features of that graph.
This is the cooling curve that was produced. You'll notice that the temperature of the acid cools rapidly at the beginning, but then it doesn't cool at all for a good number of minutes. After some point, the temperature starts to cool again. To consider what's going on, it might be easier if we imagine the graph flipped around. That is, imagine what it would look like if we were heating it up. This is a mirror image of the original cooling curve. But this isn't exactly what it would look like if it were being heated up, because it would heat up more rapidly at the beginning and then less rapidly at the end. So the graph of a heating curve would look more like this. The flat bit of the graph happens when you change state. Here the stearic acid was a solid, and here the acid is a liquid. From changing state from a solid to a liquid, the atoms get further apart as bonds between the atoms are broken. We notice there's no change in temperature as the substance melts from a solid to a liquid. And this is because the energy that's being supplied is used to break the bonds rather than simply to heat the substance. So now if we look back at the cooling curve, we can apply the same logic. The flat bit of the graph occurs at the change of state, when changing from a liquid to a solid. And we notice that there was no change in temperature as the substance solidifies from a liquid to a solid, even though it's still well above room temperature. And this happens because energy is released when the bonds form, and that keeps the temperature constant. It takes a supply of energy to break bonds, and when you form the bonds again, that releases energy. And that means that the temperature remains constant. You notice, of course, that the temperature at which that happens is a constant 54 degrees, and that's the melting point for stearic acid.
Now, in all of his discussion of bonds, I didn't hear any mention of Bond, James Bond. We'll get to that another day. All right, so back to our lab. Again, he was using stearic acid, but I have found that paraffin wax actually works much better than this under a shorter period of time in our lab. So here's what I'd like you to do. And by the way, I hope you were listening to what he said as we do our own lab. First, make sure you turn to the following page, page 82, and notice how the X and Y axis are set up here. The time is on the X axis, and we go from 0 to 15 minutes. And the temperature is on the Y axis. Did I say that right? X axis, Y axis. The temperature is on the Y axis, and it goes from 0 to 100 degrees Celsius. So I'd like you first to pause the video here and get your graph set up correctly before we gather the data. All right, now you'll notice back on page 81 that we have a data table to complete. Normally, we'd be working with a lab partner and someone would be watching the thermometer while the other is recording the data. But we're going to do this all together right now. And I have performed this experiment already, and I have gathered the data very much similar way to that video that we watched, except we used a regular thermometer in our experiment rather than a digital thermometer. And so here is our blank data table, and now I'm going to show you the completed data table, and I want to point something out to you about the initial temperature. The initial temperature at time 0 was the temperature of the hot liquid wax while it was in boiling water. And that temperature, as you know, is 100 degrees Celsius. So as you look through the data table, we gathered the data all the way out to 15 minutes and got the lowest temperature at 28 degrees Celsius. So I'd like you to pause this screen so that you can gather your data at this time. All right, now that you've gathered all of your data, it's time to plot your data points. You're going to be creating a line graph, a smooth line graph, first by plotting on the x-axis the time values and the y-axis the temperature values. So for time 0, the temperature was 100 degrees. So you're going to plot your data point at 100. At half a minute, the temperature was 90 degrees. So back to your graph, halfway between 0 and 1 would be a half a minute, and you'll plot a dot at 90 degrees. You're going to plot all of your data points until you get through 15 minutes in order to see what type of graph you come up with. So again, I'd like you to pause this video until your graph is completed. All right. Now that you've completed your graph, I'd like you to compare it with the one that I constructed here. Does it look like this? Hopefully it does. And on this graph, you will notice that there was a dramatic decline in temperature for the first couple minutes. And then there was no change in temperature for quite some time before it started to drop off again. So your line graph should look something like this. This is a phase change graph, or to use the British term, a state change graph like we saw in the video. But I have a couple questions for you. What phase or state of matter was the wax in the first part of the graph? What phase or state of matter was the wax at the end of the graph? Hopefully you responded liquid and solid, because that's exactly what it was. And so here's the next question. What was taking place? What was taking place at the time between liquid and solid at this point in your graph right here? What was happening to the wax? Hopefully you said it was, well, freezing or undergoing a phase change. Going from a liquid to a solid is called freezing, and that is a change in phase. And what was happening to the temperature at that point in time? Think about it. What is happening to the temperature during the phase change? Look at the shape of the graph and look at your y-axis. There was no temperature change. When a substance like water or wax or whatever the substance might be, when it changes from one phase to another, there's no change in temperature. Think about that. It might be contrary to your hypothesis. It might be contrary to what you think is your logic, but there is no temperature change. And my question to you would be, why? Maybe you know the answer, but the answer is because during a phase change, it requires energy, either the absorption or energy or the release of energy. And that heat energy is called either the heat of fusion or the heat of vaporization, based on which phase change it's going through. So in the case of our lab here, going from a liquid to a solid, we have freezing. It's called the heat of fusion. It takes heat energy being released in order to change phase from one phase to another. That's called the heat of fusion. In the case of water, it's 80 calories per gram that has to be released or absorbed in order to change from water to ice, or the other way around. With wax, the number is a bit higher, but you get the idea, hopefully, in observing the results from this lab, that going from a liquid to a solid, even though you might think the temperature is changing during the actual phase change, it's not. Yes, it changes from the initial point to the final point, but during the actual phase change, there's no change in temperature. Think about that as you study for the quiz tomorrow. So hopefully you enjoyed the lab today, and until next time, I'll say bye-bye.